Hi everyone. Today I'll be talking about procedural generation. Specifically, we'll be looking into generating mazes. Now, in the last iteration of our project, we worked on creating flow fields. And in short summary, the traditional way to approach pathfinding is to have every character in the game generate a path towards their destination. What we're doing with flow fields is we are basically pre-computing that pathfinding and then putting that information into the terrain, so that all the character needs to do is to query the direction they need to go from their current location. To expand on this, we want to create an interesting terrain that our characters can navigate around. So we decided to make a maze. For my part, I'm responsible for creating the algorithm that generates the mazes and then putting that into a convenient data structure. We made a graph data structure containing nodes and edges. This data structure can then be read by my teammate and then used to create the mesh for the maze. For this iteration, I'll be looking towards making a utility. Alright, so we have this maze right here that we have attached to this actor. So right now it's got a simple material that we've attached here, and if you look over here, we've got a bunch of interesting properties that you can play with. Now, first of all, you've got generate now. So when you click it, it generates a new configuration for the maze. You can even change how many cells there are in the maze. So right now there are 6 cells by 6 cells. We can change that to be even bigger if we wanted to. And it doesn't even have to be the same ratio. So we can do 15 by 10 if we wanted to, and it works just fine. Now, you'll notice that the maze is constrained to this size. If you want to make it bigger, we change the scale of the actor. So I'm going to bring it up to 2000. So, and now we have a bigger maze. Awesome. And once you're happy with a particular configuration, you can hit play and do whatever you want. But if you would like to generate a new maze every time you hit play, you can click generate on play, and every time you play, it'll generate a completely different maze. Awesome. If you think that the walls are too thick, you can decrease the size or increase the size to whatever you want. So I'm going to decrease it to 5, and now you can see that the walls are much thinner, or you can make it thicker. So how did I make a algorithm that could generate these mazes? Well, there's a couple of techniques and algorithms that you can use to generate mazes. I've chosen a really simple one. It's basically a depth first search with some backtracking on top, and essentially it means it's recursive. Now, the following process goes like this. Basically, you start with ideally a graph where every cell is covered with walls, and then you pick a random start to begin with. You go to that cell, and then you mark it as visited. And then you go through every valid neighboring cell in a random order. That means you find a cell that is not visited and is inside the maze. So it's not out of range or it's not out of index. And you do that in a random order so that you pick the neighboring cells in a random direction so you can create some variation in these mazes. And then you clear a wall towards the cell. And then finally you just repeat the same thing over and over again, which means jumping back to step 1 and then going to that neighboring cell, mark it visited, go through neighbors, and then do it over and over again. And remember, this is a backtracking algorithm, so once you've finished that process, you backtrack, you go back. Once you've recursively generated a cell, you go back and then you go to the next neighbor and then the next neighbor. Let me show you how this works in an example. All right, over here we have a graph where every cell is closed off by a wall. we pick a random cell. In this case, we're gonna pick this one and go through the process. We mark this cell as visited, and then we go through neighbors. So we're gonna do it in a random order. In this case, let's randomly pick the top one. We recursively do the same function again. So we mark it as visited, and then we pick a neighbor in a random order. We recurse it, and then do it again. Mark visited, find neighbor, and recurse it. And in this case, we'll go down, and then do that again. And now we've hit basically a dead end. We can't go down, we can't go here because this is visited, and we can't go to the right because it's visited. So now this is the part where we backtrack. So we go back to this cell, and then we go through the rest of the neighbors, which it doesn't really have any because it's in the corner. And then we go backtrack again. And we go back here, and then we go through all the neighbors. So we've been here, but we haven't been to this neighbor. So we go up and we mark that as visited. And then we do the same process over and over again until hopefully an entire maze is generated. Now, the cool part about doing this whole recursive and backtracking thing, because the way the whole backtracking works and the way we iterate through all the cells, we kind of iterate through everything. We visit all the cells in one go with the backtracking. So that means that every single cell in the maze is basically guaranteed to have a path to another cell in the maze. So as you can see here, every cell in the maze is reachable from one or the other. So if you would like to have a entrance and exit, and then you could maybe have this thing where you have to go from one side to the other side of the maze, you could literally just knock a wall on one side, knock a wall on the other side, and you're basically good to go. When you bring in together the procedural generation of mazes and the pathfinding of flow fields, you can get something that's pretty cool. Now, the best part about this project is if there are some problems or if you don't like the maze that you're looking at, you could always generate a new one and be happy about it. And in fact, if you want something really unique, you can generate a new maze every single time you hit play, so it will always be different. And yeah, you can even, if you really want to, if you think it's too small, you can always change the sizes. You can make it bigger, like so. And yeah, so this has been our project. Now, I think in the future, what we really want to do is we want to maybe we could do some improvements, making the terrain better, make it more interesting, make the maze more interesting, maybe make some cool corridors, like by adding some props or whatnot. That's something to look into. Not really sure we're gonna do that. We can also improve the pathfinding and the avoidance for the agents over here because it's not perfect. It could use some tweaks. And I guess for multiplayer, I actually wanted to do some sort of interaction between the walls. So maybe one player could close off one wall or open one wall, and the other player could compete or cooperate or do something with it. We haven't really decided. That's what I'm hoping to look into. And yeah, for handling how multiplayer will work in the future, I think most of the systems can be put into the backend or the server. So most of like the agent movements and avoidance and like the generation, everything can be moved to the server, and you could send like locations of agents into the client, and you can even send the maze graph data structure to the clients as well. And even the flow, you can even send the flow fields as a texture, or actually just send it. And yeah, so I hope you enjoyed this video. Thank you for listening in.